Okay, so our last topic today is multicollinearity, and this is um, another step in making sure you have a good predictive model. In addition to building your regression, if somebody asks you to create a model that has certain variables in it, you might want to say something about any issues with multicollinearity before they use that model. So, if if you don't get the chance to build a model with only the significant predictors. So, how do you know if you have this issue? Well, you're going to check it out, the correlation table and your coefficients. And the effect is that you have highly correlated predictor variables. And what that can do is wreak havoc on the coefficients in terms of their sign and their size. So if you have highly correlated coefficients or highly correlated predictor variables, they could be explaining the same thing. So we talked about age and tenure at your job, right? So they are essentially getting at kind of the same thing, how long you've been there, been alive, right? So and when we put them in the model, they're fighting to explain the same variation in the outcome, and so it can create weirdness in the answers. So we're going to check it out. So if we go back to our data with the crude oil production, and we run the correlation. So I put it right here. So we see that in terms of the correlation of each of our predictors with the outcome, it's all positive. And so one thing to note is that the sign of the correlation should be the same sign you get for the coefficients. So these are all positive. So you should get positive coefficients. But we also see that there's really high correlations. And this can mean that these are essentially measuring the same thing. So if you get the option, although somebody says, I want a model with these 5 predictors in it, you might say, well, what this is suggesting is that X2 and X3, so U.S. energy consumption and U.S. nuclear generation, are just about equally as good in what they're representing, right? Or X5 and X2, or X3 and X5, right? So these are telling you that they're giving you, almost a one-to-one match in terms of their relationship. So they may be replaceable in the model. And in fact, if we go to the output that we were just playing with, so when we drop them all in the model, if we were to look at the coefficients, you would notice that some of these are actually negative. Well, why are they negative? It's because they fought first to explain the variation and these lost, right? So there is some issue of multicollinearity, and you would want to think about which of these variables to drop. Now, there's no, in our case, we're not running any tests, so you have to use your judgment of which ones you might want to drop. You could do it by the worst p-value. You could do it based on the correlation, which one replaces another one. But one thing to ensure is that your final model, the coefficient should have the same sign as your correlation with the outcome variable. So that's the issue with multicollinearity, is it's a little bit of a protector. For you, if you were to give somebody a model, you don't want to give them something that's totally wrong. So you want to make sure as a check that these coefficients are all of the same sign as their correlation with the outcome. And then the best option is if you get to build a model, because then you can ensure that the best predictors are in the model. All right, that's it.